Hi guys! Salamat at hindi niyo ako iniwan dito sa ating ginagawang discussions about spiral transition curvature. At gaya nga ng nabanggit ko sa ating discussions ngayon ay papakita natin ang derivations of the different elements of spiral transition curvature. Gaya ng nauna nating discussions, we have already discussed the super elevations. Then the discussion was followed by the discussions of the properties and elements of spiral transition curve. At ngayon ay puntahan na natin itong ating discussions about the derivations of the different elements. So magsimula tayo sa spiral angle at any point on the spiral. Diba? Ano nga ulit itong spiral angle? Yun yung angle that the tangent drawn to that point on the spiral will be making with the tangent distance. Kaya kung ipapakita natin, halimbawa meron tayo ditong differential length. Kumuha muna tayo ng isang maliit na length ng spiral. Sabihin natin that this is our differential length. And this is our tangent distance. Di ba? This is our point on the spiral. We call this as any point on the spiral. Okay? Sabi dito, if we're going to draw tangent to this point on the spiral, then this angle, itong angle na to, will be our spiral angle. At sabihin natin yung spiral angle is given by d sa best. Why d sa best? Kasi maliit lamang, ds, kasi maliit lamang itong length na ito, it is just equal to dl. Sa mga tuwid, yung spiral angle na mabubuo between the tangent and the tangent to that point will also be very, very small. And let that small angle be denoted as ds. Diba? Ayun, dahil nga maikli lamang itong dl, then we would expect, we would expect that if we are to draw a radius, sabihin natin, meron tayo ditong ds. Itong radius na ito na ma-obserbahan natin na, dahil maliit lamang yung dl, sabi dito, because the length is very, very small, the radius on the left of that dl is equal to the radius on the right. Unlike dito sa nakikita natin dito, if you have here the entire length, the radius on the left, diba, will be longer than the radius on the right. But because this dl is very, very small, therefore, itong radius na ito dito will be equal to the radius here. So that if we will be calling this radius r as r, therefore, this radius will also be called as r. And that r shall be called as the radius of the curve at any point. Diba? Now, kung titinan natin dito at i-recall natin yung ating understanding about trigonometry, sabi dito, for a subtended angle in radian, the arc length dl is equal to the product of the radius and the subtended angle. Diba? Kung meron daw tayong angle in radian, then the arc length dl will be equal to the product of the radius and that subtended angle. If the subtended angle is expressed in radian. So that, in this case, yung ating dl will be equal to the r multiplied by that differential subtended angle ds. Right? So that if we are to simplify and solve for ds, because we are looking for ds, so our ds therefore will be equal to dl over r. But kanina lang ay na-mention natin, napag-aralan natin yung property ng spiral transition curve. Na sinasabi that the radius of the curvature is inversely proportional to the length of the spiral. Na-discuss ko kanina. If this will be rewritten, if this property will be written in symbol, we again say that the radius of the curvature, the radius of the spiral at any point is to r sub c shall be equal to the ratio of L sub c divided by L. And we are interested on the value of r. Therefore, if we will simplify, we can solve for r to be equal to the product of r sub c multiplied by L sub c divided by L. Diba? And if this r will be substituted here, kapag sinubstitute natin dito, ano ngayon ang mangyayari? Makukuha natin yung ds, which is actually equal to the product of L, yung L kasi magiging numerator, di ba? So the product of L multiplied by DL divided by R sub C, L sub C. At ano ngayon meron tayo? Actually, we have here a differential equation. The differential equation which can be analyzed and solved by integrating both sides of the equation. That if we integrate both sides of the equation, what will be our equation? Our equation becomes the integral of ds equal to the integral of L squared dl over R sub c, L sub c. And that if this will be simplified, then we shall be getting the formula for S, and that is S equal to L squared over 2 L sub c, R sub c. So we have already derived one formula, and that formula is for the spiral angle at any point on the spiral. So, when we are talking of the second element, sabi dito, what about the spiral angle at SC? Tandaan natin that there is a relationship between the spiral angle at any point and the spiral angle at SC, because we note that at SC, yung length ng spiral is already equal to L sub C, di ba? Yung L natin will be equal to L sub C. So that if this will be substituted, that L is equal to L sub C in this formula for S. Ano ngayon ating mangyayari sa S? Ang ating S will become S sub C. And this will become L sub C, and that our equation becomes equal to S sub C equal to L sub C squared divided by 2 times L sub C times R sub C. And you will notice that itong L sub C natin will cancel. At ang matitira dito, that S sub C will be equal to L sub C over 2 R sub C. Take note that this S sub C representing the spiral angle at SC is expressed in terms of the radius of the curvature. What if we are given the degree of the curvature? Therefore, we have to express also S sub C in terms of the degree. Understanding that the degree of the curvature is the angle subtended by a chord of 20. Therefore, we can find the relationship that R sub C will be equal to 20 over D sub C. But if we are given D sub C, that is because 20 is D sub C is the angle subtended by a chord of 20. Sa makatuwid yung ating R sub C will be 20 over D sub C. And that if R sub C will be substituted here, ba? Ano ngayon ang mangyayari? Makukuha natin yung S sub C expressed now in terms of our degree of the curvature of the simple curve, and that is equal to L sub C D sub C over 40. Okay? So, next element that we will have is the offset from tangent at any point on the spiral. Ano nga yung ating offset from tangent? It is the distance from the tangent to any point on the spiral. So, para makita natin yan, let us try to imagine that we have here our tangent distance. And here is our TS. And from TS, we draw a spiral transition curve at meron tayo ditong any point on the spiral. Diba? Now, sabi dito, kung sakali, if the length of the spiral, if this length of the spiral shall be subdivided into smaller lengths, such as DL. Kung sakali daw that this will be subdivided into very, very small lengths, and that length has a distance equal to DL, simula sa ating TS, papunta hanggang sa dito sa ating any point on the spiral. Di ba? Then, the total offset of the point on the spiral shall be the sum of all the components of that DL perpendicular to the tangent. At para maunawaan itong ating discussion nito, ipakita natin that we try to subdivide this into differential length. Halimbawa, sabihin natin that I have here the point, and this is actually the first differential length. Maikli lang itong length nito, bagamat yung point parang nakita natin mas maliit kaysa dito. Baka nga mas malaki pa yung point kaysa sa differential length. Diba? So, imagine natin that we have here another point, so that we have here the differential length, and we have here the point. That point has a length equal to differential length, and so on and so forth. Pakita natin na may mga differential length tayo dito hanggang sa dulo. Okay, so these are our differential length that are used to subdivide our total length of the spiral up to that any point. Diba? Yung sinasabi natin dito, okay, offset from tangent, actually daw, is the summation of all the components of this differential length perpendicular to the tangent. Hence, if we are going to resolve this differential length into components parallel and perpendicular to the tangent, then this is what you will have. Okay, this can be resolved perpendicular and parallel, di ba? Also, this differential length, this differential length, that differential length, this differential length, and up to that length, di ba? Meron tayo ngayong vertical and horizontal. The vertical and the horizontal, or the component parallel and perpendicular to the tangent. Now, alin ngayon yung tinutukoy nating offset from tangent? The offset from tangent will be the distance from here up to that point, and that actually is the summation of all those components of the lengths of this triangular triangular figure from this tangent. So, pakita ulit natin yung animation para ma-appreciate natin. Here is the distance, and that will be our x. We call this as our x, the offset from tangent at any point on the spiral. Para lang makita natin. Now, to derive the formula, let us try to consider the triangle, this particular any particular triangle, and let us imagine that we will be using this triangle in my derivation. Here is our DL, pinalaki ko lang ng konti, This will be very, very small. Let us call this as our dy, as well as this as our dx. Okay, tandaan natin that this will be a right triangle, and imagine natin that this angle, by the way, how much is this angle? This angle can be taken by going back to this figure where we take the triangle. This triangle, this DL actually is the length tangent to the point. So that if we will be extending this this DL up to that point, meron tayo ngayong tangent distance. And this angle, by definition, is actually called as the spiral angle at any point, and that is called as S. Sa makatwid, this will be S. Diba? Now, because you have here a right triangle having S as the angle, you have the opposite and the hypotenuse. Therefore, you can come up with the function of the right triangle, so that sine of S will be equal to dx over dl. Right? But for if if S is very, very small, and if S is expressed in terms of radian, therefore our small angle, for small angle in radian, we say that yung sine of that angle is approximately the same as the angle in radian. Kaya if this will be substituted here, therefore what will be our equation? Our equation will become S equal to dx over dl. At alin ang tinatarget natin? Ang tinatarget natin is this dx. So that if we will simplify and solve for dx, dx will be equal to the product of S multiplied by dl and this one. But kanina, we just have solved for the value of S, di ba? We just have solved for the value of S, and that S is equal to L square over 2 L sub C R sub C. Ngayon, kung ito daw isa-substitute natin dito sa S, ano ngayon ang mangyayari? Ang ating dx will become L square over 2 L sub C R sub C multiplied by dl. Di ba? So what shall we do then? So because this is a differential equation, we can simplify and we can solve for x if we will be integrating both sides of the equation. So if we will be integrating both sides of the equation, this becomes our integral of dx shall be equal to the integral of the quantity L squared dl multiplied by 2 L sub c R sub c. And what is the integral of dx? The integral of dx is x. What's the integral of this one? So you have L squared will become L cubed, and 3 will be multiplied by 2. So this becomes what? X becomes L cubed over 6 L sub c R sub c. And this becomes now our offset from tangent at any point on the spiral. Now, if we will be talking of the offset from tangent at SC, ano ngayon ang mapapansin natin? Tandaan natin, at SC, yung length of the spiral is already equal to L sub C. Kaya kapag isa-substitute natin ito dito, yung ating X will become X sub C, or the offset from tangent at SC. And this becomes X sub C, diba? X sub C equal to LC cube, divided by 6 times LC R sub C. And you will notice that K3 here will cancel with L sub C. Ang matitira dito is only L sub C square. Okay, so you will have therefore a formula for the offset from tangent at SC, and that is equal to LC square over 6R sub C. Okay? So the next puntahan pa natin yung ating next element. Yung next element naman natin will be the distance along the tangent at any point on the spiral. At pag sinabi nating distance, it is the point, okay, the distance that is measured, okay, from TS along the tangent. So to show that, let us imagine again that we have here our tangent. Okay, here is our point, and then we try to draw our spiral angle, so that this will be our any point on the spiral. And again, if we will be talking of the measured distance from this point, so malalaman natin that that any point will be can be taken by subdividing this length into a differential length. Sabi nga dito, gaya ng ginawa natin kanina, if the length of the spiral shall be subdivided into smaller lengths, such as DL, starting from this TS hanggang dito sa ating any point, then the distance of the point along the tangent shall be the sum of all the components of DL parallel to the tangent. Ngayon, ipakita natin na halimbawa sabihin natin that we consider here this point so that this length will be our DL. Meron tayo ditong point at meron siyang, ang length niya is DL. Okay, we have here the point, ang kanyang length is DL. So, same is true here, okay, until we reach the last point, or we call that as the any point on the. So what shall we do therefore is to resolve this differential length and show the component of that DL parallel and perpendicular to the tangent. And let us imagine that these are drawn parallel and perpendicular to the tangent, and this will actually represent a triangle. The perpendicular lengths are those line above the triangle. And if all of those lines shall be accumulated, shall be summed up, then we shall be getting our tangent distance along the tangent. And let us try to show this by the use of the animation. Ipakita natin yan, pag nagsama-sama ngayon yan, we will be getting our distance along the tangent at any point on the spiral. And to get that, let us try to consider again any particular triangle, and we'll be taking this triangle again para maipakita natin yung kanyang magnitude. Here is our DL, ito yung kanyang DY, ito naman yung kanyang DX, di ba? So how are we going to solve for DY in terms of this element? Di ba? Kung natatandaan natin, we have learned in our elementary surveying a concept of how do we get the horizontal distance if we are given or we know the inclined distance and the vertical distance. Let us try to recall one particular concept. But before we do it, let us try to identify this angle again. Again, this angle will be taken as the angle that this DL will be making with respect to tangent, and we know that that is our spiral angle. This will be our S, di ba? Now going back to this concept that we wanted to determine the horizontal distance in terms of the vertical and the inclined distance by recalling our concept that we learned in our surveying, that the slope correction formula. So the slope correction formula can be explained by this triangle. Imagine that we have a triangle, we have an inclined distance given by S, a vertical distance given by H, and a horizontal distance given by a Y. Diba? So how do we solve for the Y? Sabi dito, yung the horizontal distance is equal to the inclined distance less the correction due to slope. So that if we are going to solve for the horizontal distance, therefore our horizontal distance y will be equal to the inclined distance s minus the certain correction c. And what is this correction? Yung correction daw will be equal to the square of the vertical distance divided by twice the inclined distance. So that this is equal to h squared divided by 2s. And if this concept will be applied dito, will be applied here, di ba? Pag in-apply natin siya dito, how are we going to get our dy? So, kunin natin, ano ba yung ating horizontal distance here? So, we shall be getting dy will be equal to the inclined distance minus the correction, where the correction is the square of the vertical distance given by dx, twice, divided by 2 of the inclined distance, dl. Right? So you have now our formula for dy, but this is not yet true because you have here our dx. Now, we learned that dx, right? We learned that dx, yes, we learned that dx is how much? S multiplied by dl. Kanina, pinakita natin yung dx natin is equal to s multiplied by dl, di ba? That if this will be substituted here, yung ating dx will become s squared multiplied by dl squared. So this becomes dy shall be equal to dl minus s squared times dl squared divided by 2 over 2 dl. And again, you will find that these 2 will cancel with dl here, and we shall be getting that dy will be equal to dl minus s squared multiplied by dl divided by 2. Now, let us try to recall that S is already taken and computed as L squared over 2L sub C R sub C. But therefore, if this will be substituted to this S squared here, so our dy will become dl minus L cubed, L to the fourth, because L squared will be squared further, multiplied by dl divided by the square of 2 multiplied by 2, that becomes 8. So you have LC square R sub C square. And again, you have here a differential equation, which can be simplified by integrating both sides of the equation, so that the integral of dy will be equal to the integral of dl minus the integral of L to the fourth dl divided by 8LC square R sub C square. And then integrating the equation, so you will have here the equation for the distance along the tangent, which is equal to y, shall be equal to L minus L to the fifth, divided by the product of 5 and 8 will be equal to 40. L to the fifth divided by 40, L sub C square, R sub C square. And this is now our formula for finding the distance along the tangent at any point on the spiral. Now, if we're going to solve for the distance along the tangent at SC, knowing that at SC, the length of the spiral is already equal to L sub C. Therefore, we substitute the value of L sub C here in L, and Y will become Y sub C. So that Y sub C becomes equal to L sub C minus L sub C cube, because L sub C here will cancel with that. So that becomes 40 times R sub C square. And that is our formula for finding the offset from tangent, or the distance along the tangent at ST. Guys, mayroon pa tayong ilang mga elements ng spiral transition curve na kinakailangan pa nating i-derive. Kaya huwag nyo akong iwan guys, patuloy nyo ko sundan sa ating gagawing discussions. Kaya subscribe and share this channel para naman yung mga kaibigan mo ay ma-notify din of these uploads. Once again, thank you very much for watching.